here we are at 10.2.3. How is it changing? This is the very last piece that we're going to do from the textbook, unless we assign things from the back of the textbook. This is about analyzing data to identify a trend. Have you ever tried to figure out whether you could earn enough money to be able to buy something that you wanted? In this lesson, you will consider the relationship between the time you work and your pay rate as you work to analyze data and make predictions. We'll do this together. For 10-88, Devin hopes to get a summer job at an amusement park. His goal is to earn enough money during the summer to buy a laptop for $875. He is not sure what pay rate he will be offered, so he asks his friends who work at the same amusement park for information from their last paycheck. The information he gathered is in the table at the right. On graph paper, you are to set up a graph, carefully decide how to scale the axes, and graph Devin's data. You might want to do this in your composition book if it contains graph paper. So I want you to pause the video and I want you to try this on your own before you continue. Once you have created your graph, you're going to be drawing a trend line. You can do it now or later, but I want you to think about, is it reasonable to have your trend line go through the origin and why? So now that you're back, your graph should have looked something like this. It might not have looked exactly like this, but similar. This is my sample answer. I used intervals of 50, making the tick marks every 100. And on the bottom, I actually counted by 2.5 on my graph paper, but you'll notice I have tick marks at 5 and it's labeled every 10. My trend line, while I don't necessarily agree, I put it through 0, 0, and this was the result. From here, I can try to find a slope triangle. So I decided to use the x-axis down here as part of my slope triangle, and then I went from 80 up to this point, which is at 750. This made it easy for me to count because I knew then that this would be at 750 for the rise or the y or the change in y, and then I knew as I counted along that the bottom would be at 80, and that's why I chose to put my lattice points. Now note, this point was not here. I just happened to notice that my line went through that point. I could have used this, but notice it's not quite at 20, so I wouldn't have gotten the same result. So I'm saying that my slope for this particular graph is 750 over 80, which gives me 75 over 8. And so that would be my slope. You'll notice that my y-intercept is 0. So if I were going to write an equation for this line, I would say it's y equals 75/8 x. Plus 0, but I'm not going to put that. So that's what I got here. So I'm saying that this is a proportional relationship. However, I'm going to show you something that I got in a spreadsheet. So I put the data into Google Sheets. The first set of data that I used was without 0, 0. And when I pushed the trend line, it created it here, which you'll know that the y-intercept looks like it would be approximately, if this is 300 and this is 50, I'm going to say about 210. So I would say about 210 would be my y-intercept, and then my slope I would have to figure out from there. So this was a little different where my y-intercept would have equaled 210, and this is without using 0, 0. Here I put 0, 0 into my table and then had the trend line do the graph, and notice how it almost goes between this point and this point. I could actually use that information because I know what those points are, but notice it did not go through 0, 0. So this was another way. So there was the way I did by hand, the way without 0, 0 in the table, and then the way with 0, 0 in the table. So you get 3 different examples. The next thing I did was use Desmos, and I looked at 3 different possible trend lines going through the origin. The black line here, as you notice, has the same slope as mine. I went ahead and I drew this on here. These points right here, which have green highlights around them, represent the points from the table that I had put in. And you'll notice that my black line does not go through any of them. It gets close to this one and pretty much looks like it might be going through that one. Then I tried something different. I got it to go real close to this and this one. This is the last point at 8,700. And I looked to see what that would be. And I have y equals 35 over 4. And that would represent the 700 over 80. So it's a little different than mine. And then finally, I created the green one. And the green one is going through these 2 points, which was similar to one of the graphs previous. And I got a slope of 48 over 5. And so here's 3 different possibilities. And down here, you see the one that I did by hand. Which one is the best last answer, it's hard to say. Later on, you're going to be asked if Devin has enough money to buy the laptop, and this graph will tell us, so you'll be able to look at 120 hours and determine whether or not he can. We're going to find the hourly rate for each of Devin's friends, the dollars per hour. So let's do that now. I have this set up here, and we're going to call pay Y and the time X, and it's going to be Y over X, not X over Y, because we're doing the change in Y over the change in X. This does represent a slope, but it will give me how much money they make per hour. So it'll give me a unit rate. So that is what I'm going to do. So for the first one, we're going to do 200 divided by 21, and that equals approximately $9.52. For the next one, we're going to do 305 divided by 25, and that equals $12.20. For the next one, we're going to do 252 divided by 36, and that equals $7. And then we're going to do 480 divided by 50, and that equals $9.60. We're going to do 600 divided by 55, and that equals approximately $10.90. Actually, it's 9090, so I'm going to say approximately $10.91. I'll round it up. Now we're going to do 512 divided by 64, and that equals $8 an hour. And then we're going to do, I'm going to move this over a little, 600 divided by 72 for approximately $8.33. And then finally we have 700 divided by 80, which gives us $8.75. So now we have each of their hourly rates. We're going to go back and look at the next answer. It says, what is the highest rate per hour one of Devin's friends is earning, and what is the lowest rate per hour? So we got our unit rates, so we're going to go back and we're going to look. Ben appears to be making the most, so he would be the highest amount. And as we look down here, let's see, it looks like $7 is the lowest. So that means Emery is making the lowest amount. So we have $12.20 and $7. So we have $12.20 and then $7, the highest and the lowest. Draw a trend line that represents this data. We've already done that, so we'll look at that. Use your trend line to help Devin predict how much he will earn. Why does it make sense that the trend line should pass through the origin? Well, I don't necessarily agree with this, but the reason would be if you worked 0 hours, you make 0 money. So you are being asked to put it through the origin, which I did. It's because if you work 0 hours, you make 0 money. Devin hopes to work 4 hours each day. So let's do that. 4 hours. If he works Friday through Sunday, Friday, Saturday, Sunday, that's 3 days, and he works for 10 weeks, how many hours would he work? So I'm going to say 4 hours each day for 3 days for 10 weeks, and that's what I'm getting. So I'm getting 12 times 10, which equals 120 hours. So I'm getting 120 hours. Based on the trend line, how much money can Devin expect to be paid per hour? Show how you found your answer. Answers will vary based on the trend line. So I'm going to go back to this item right here, and I'm going to look at 120, and I'm going to follow the line up to find for my different lines here. Now this one here was mine. Devin knows that he will need to pay 7.5% tax for his laptop. Will he make enough money? Explain how you know. Devin's laptop cost $875, the one that he's looking at, and we need to multiply that by 7.5% or 0.075. That would be 7, because remember this is 7.5 divided by 100, and if we move the decimal point one place over, we get 75 thousandths, and that's what this is. This will tell us the tax. So he's going to have to pay $65.63 approximately, $65.63. And this is an approximation in tax on this computer. That's a lot of money. So we're going to do $875 plus $65.63 to see how much money he needs. 0, 8, 1. Okay, doing this by hand, I'm getting $940.63. Now, there's another way I could have got the answer right away. Since this is 7.5%, I could have just multiplied by the amount that he would pay of that, and I could have got the same answer. So in other words, I could have subtracted this from 100% and then multiplied by that number, and it would have given me the answer of $940.63. Now, the question is, will he have enough money? And as you recall, looking at the graph before, each of the amounts along the line, no matter which trend line, showed that he would make over $1,000 in that time frame. What if he only makes $7? Well, let's figure that out. 7 times 120, because we decided it was 120 hours, would he make enough if he only was making $7 an hour? So 7 times 120 is $840. So if he only makes $7 an hour, it would not be enough, but most likely he will be making enough. So now that we are all done, I want you to go and watch the equation of a trend line video. That's your extension of today, and take notes on that. It will explain in more detail how to write the equation. And then I want you to watch the video on Fraction Busters. It is a review of something we've done before, but it has more detail added to it. So please watch it. Both those links are in your Google Classroom. So that's what you're going to do for the rest of your 80 minutes. The videos are not very long.